नमस्कार दोस्तों, मैं आपकी होस्ट शिप्रा एब्राहम डिजिटल इंडिया आस्क आवर एक्सपर्ट्स के 36th एपिसोड में आपका स्वागत करती हूँ। डिजिटल इंडिया आस्क आवर एक्सपर्ट्स इज अ स्पेशल लाइव सीरीज ऑर्गेनाइज्ड बाय द नेशनल ई-गवर्नेंस डिविजन, मिनिस्ट्री ऑफ इलेक्ट्रॉनिक्स एंड IT. Here you learn about various Digital India initiatives and ask your queries directly to the experts. Friends, today's episode is a futuristic one because we are going to talk about quantum security. मतलब उन टेक्नोलॉजीज के बारे में जो हमारे डिजिटल लेन देन, कॉन्फिडेंशियल डेटा, बैंकिंग, डिफेंस और कम्युनिकेशन नेटवर्क को क्वांटम लेवल सिक्योरिटी देते हैं। अब ये क्वांटम लेवल सिक्योरिटी होता क्या है, क्वांटम टेक्नोलॉजी क्या होती है, इन सब के बारे में समझाने के लिए हमारे साथ मौजूद हैं हमारी एस्टीम्ड गेस्ट डॉक्टर आनंदिता बैनर्जी। आई वेलकम यू टू द शो, मैम।
Thank you.
Dr. Banerjee is a senior scientist at C-DAC Pune who leads various quantum-related initiatives. At present, she is working on fiber QKD, QRNG and aerial quantum communication platforms. इन टर्म्स को सुन के डरिएगा नहीं क्योंकि डॉक्टर बैनर्जी हमें अभी इन सब के बारे में बताएंगे। तो बिना किसी देरी के चलिए शुरू करते हैं अपना डिस्कशन ऑन क्वांटम लीप्स। चर्चा के दौरान आपके मन में जो भी सवाल आए क्वांटम कम्युनिकेशन, क्वांटम सिक्योरिटी को लेके, कृपया अपने क्वेश्चंस को यूट्यूब चैट में लिखिए। मैं उन्हें डॉक्टर बैनर्जी को प्रस्तुत करूंगी जो आपके सवालों का उत्तर इसी शो के दौरान देंगी। और आपके सवाल आपको सिर्फ उनके उत्तर ही नहीं बल्कि आपको डिजिटल इंडिया क्वेश्चन निंजा का रिवॉर्ड भी दिलवा सकते हैं। सो फटाफट से क्वांटम कंप्यूटिंग से रिलेटेड, क्वांटम कम्युनिकेशन सिक्योरिटी से रिलेटेड अपने क्वेश्चंस यूट्यूब चैट में लिखना शुरू कीजिए। मैम, वी आर सेलिब्रेटिंग द इंटरनेशनल ईयर ऑफ क्वांटम साइंस एंड टेक्नोलॉजी। प्लीज टेल अस समथिंग अबाउट इट।
So let me start with by saying that we are already using the products from the first quantum revolution. So the first quantum revolution was focused on studying the behavior of quantum entities, quantum particles, and how to utilize the collective behavior, the collective participation of quantum entities. And we have lasers, we have GPS, we have transistors. And with that, we are moving towards second quantum revolution, which is nothing but the art of engineering to manipulate each and every quantum entity to get something useful out of it. And this brings us to technology products like quantum computer, quantum communication, and also, having advantages in various other fields where you need enhanced accuracy, high time precision, and also bringing new products or new solutions on table.
Thank you, ma'am. This brings me to this very basic question. What is quantum computing and how is it different from today's computers?
Right. So here again, I think I want to go back to that first question and add here the 100 years, which the anniversary we are celebrating. It's about the groundbreaking paper of Heisenberg. And that paper laid the foundation of the mathematical foundation for modern quantum theory. So that's what is important. So moving to your next question, which is what is quantum computing?
Right, ma'am.
So the word computing, means computing or information processing. And quantum computing is nothing but processing the information using the laws of quantum physics. So this would mean that you will be using those entities or those physical entities which obeys the laws of quantum physics, which is in the microscopic domain, and particularly atoms, electrons, photons, of that order. So in quantum computing, we are using the special powers because now we are moving in the quantum quantum information domain, quantum mechanic domain, quantum world. So we are getting some special powers, and through that we are able to solve some computational problem, or we are getting some superpowers to solve certain computational problems, bringing new products in market, bringing new solutions on table. So that is all about it. With that, I would also like to touch upon the difference between a bit and a qubit, and also to tell you what are these special powers which comes along with qubit. So bit is a binary unit of information. It is either 0 or 1, and qubit is the quantum analog of a bit. It is 0 and 1. Okay, so now that opens up multiple possibilities. Let us try to visualize it. So we have a light beam, hitting or interacting with a beam splitter. So when the light beam goes into the beam splitter, you will see the light beam coming out at two paths, transmitted path and the reflected path. Okay, and with half the intensity. Now what happens when a photon, a particle of light, interacts with a beam splitter? So after passing through the beam splitter, it emerges out, or it has its existence in both the paths simultaneously. The two paths are distinct. So my transmitted path can be a logical 0 state. My reflected path is a logic 1 state. So it is actually staying in 0 and 1. And how it is useful to me. Now, if I'm applying a quantum NOT gate on after the beam splitter, okay, so I'm doing an inversion of two logic states. So I'm able to process two states with one qubit. So the 0 becomes 1, the 1 becomes 0.
Yeah.
So if you have a classical NOT gate, you give an input 0, it becomes 1. Then again you give an input 1, it becomes 0. So this is the power. If you have two qubits, it goes to 2 to the power 2 because it's binary qubit, 2 to the power 2, 4 states. So you are able to process 4 states simultaneously. Now look at its power. If you have an exascale supercomputer, it can process 10 to the power 18 states, operations in 1 second. But a quantum computer with 60 qubits, 60 logical qubits, can act on 10 to the power 18 states simultaneously. So you look at the power of a quantum computer, that is the computational space I'm talking about.
Yeah.
With that also comes the quantum entanglement. So quantum entanglement is when the two particles, they share a special framework, or say a special relation, such that any operation you do on the first particle, the second particle responds to it simultaneously. Now this is a non-local phenomena, and many famous physicists, scientists were not comfortable with it. And after a lot of deliberation, scientific deliberation, it was then we were able to experimentally qualify that quantum entanglement exists. So all the efforts to question the principle actually led to its establishment. And we have performed quantum teleportation, different applications out of the quantum entanglement. So that's a reality which has happened long back. And now we are trying to take those applications or those experiments out from the lab to do something useful to the society. So that is how it has come. So I have spoken about a bit, a qubit, the powers, but I did that in a very brief fashion.
Yes.
We can have more questions.
Yes, ma'am. So ma'am, you spoke about that all is being done to help the society at large. However, we have heard that some people ask that is quantum computing seen as a threat to current encryption systems, and why or why not?
This is a very good question. So a threat, why a threat? It is because the modern cryptography is based on the hardness of mathematical problems. Now, it is based on computational security, which means that it is very unrealistic to break the cryptography with in terms of time and computational power. So you have a modern quantum classical computer, so it's very unrealistic. It will take billions of years or millions of years. So those mathematical problems which are considered hard or one way, now in the quantum world there exists quantum algorithms that can break those mathematical problems in reasonable time. So if you are more interested, I would like you to suggest reading those algorithms which comes under the bounded error polynomial time class, complexity class. Two of them I would like to mention here is the Shor's algorithm, the famous Shor's algorithm, and there it can factor large numbers, then it can also solve the discrete log problems. And the other one is the Grover's algorithm. Now these algorithms are very basic algorithms. Now to make it really useful, it needs a hybrid architecture, a hybrid platform. The algorithm has to be done in a hybrid fashion. But having said that, the Grover's algorithm, it actually increases the brute force attack on the symmetric key cryptography. So a key which is 256-bit key is only useful as a 128 if you have a quantum computer. So fine, one would say that we can keep on increasing the key size, but again that would add to the bandwidth latency. So it's not realistic. Now I told you about the classical problem, I told you about the quantum algorithms. Now these algorithms can be only useful if they are actually implemented on a quantum computer. So when you're computing on the quantum states and not classical computer. So a quantum computer, we know that everybody is trying to realize a fault tolerant or a crypto cracking quantum machine, but it will be so it is becoming a reality, and the time when it will be a reality depends upon when we are able to scale down the error margin from 1 in 100 or 1 in 1000, which is now, to 1 in million, which according to the most pessimistic world view, should be a reality with a probability more than 50%, or say between 50 to 60% in 10 years. So the threat is against that class of attacks called harvest now and decrypt later, where any state actor could, they can store the information, and then they can wait for a quantum computer to break it open. Now here again, I would like to emphasize on the Moscow's law, the famous Moscow's law, which says that if there is a shelf life of the data, the shelf life and the migration time, if it is more than the arrival time of a quantum computer, then your data is compromised. So if you go backwards, you have the most pessimistic view telling 10 years, 10 to 12 years, and the migration time of any crypto architecture is not less than 5 years, right? Yeah. So then you can imagine any data, the shelf life of the data, you can keep the threshold. So it is time to act now. Quantum is a reality. We have been using quantum, and we are moving towards the second quantum revolution. United Nations have recognized the matter, and so this is the time to act now.
Right. Thank you, ma'am. Ma'am, now let's talk about the fault-tolerant quantum computers. What are they, and as their development progresses, how should organizations prioritize and implement the transition to post-quantum cybersecurity?
Okay. So when you're asking about what is a fault-tolerant, so now this is something very different from a classical computer. Right, because a classical computer, it gives any algorithm you put in, the response is pretty quick, and the chances of errors are also very less, of the order of, I think, 10 to the power 13 or 15 orders. Now we have built a single qubit quantum computer, photonic qubit quantum computer in lab, and when you look at it, you will, when we show the the video of it, it shows the probabilities of error. It is never 100%. Okay, so a beam splitter simulated version will give me 50% outcome at one of the ports, 50% of the other port. But a beam splitter may not have an exact 50-50 split.
Okay.
The detectors I'm using is only 10% efficient, depending upon the wavelength. At most, it can be 65 to 70% efficient. And some advanced, super advanced detectors are 85 to 90. Nobody is touching 100, right? Now, this is one small operation which had shown conversion of a NOT gate, right? But imagine an algorithm having complex gates. So you have to implement those gates. So what is the fidelity of those gates? And then you have to do a lot of operations altogether. So a fault tolerant actually looks in totality the total error from that algorithm and tries to minimize the error margin such with respect to the qubits performance, gate performance, the algorithm performance, and achieve near perfect results. Right. So it is more from the outcome of an algorithm. It is a more realistic approach. Okay. So, once you have a fault-tolerant quantum computer, you would be calling the qubits as logical qubits. Today we have noisy qubits, and I just told you why.
Yes. Right. Thank you, ma'am. Ma'am, since you're working on the QKD part, if you can please explain us in simple terms what is QKD and how it works.
Yeah. So I will tell you about the migration to PQC as well.
Right.
So let me start with quantum key distribution.
Right.
So here we are using, or we are solving the problem of key distribution, which is classical, using laws of quantum physics. So we know that only the microscopic entities like electrons, photons, they obey the laws of quantum physics. So we will be using them to perform to solve the problem of key distribution. Now, for people who do not have an idea, let me just say that, okay, if I'm sending, if I'm keeping some materials in my suitcase and I'm locking it and sending it home, my daughter would want to open the suitcase. So she will call me and ask for the key, right? So I am disclosing the key over a phone. So that is my classical link. And this is the key distribution problem. And in the classical world, there is no definite way to guarantee that there is no eavesdropping happening. Somebody can tap, somebody can clone, somebody can monitor the movement. So this is the quantum link I was talking, right? Now, using the laws of quantum physics, I will be able to ensure that any monitoring or any tapping which is happening over the key distribution link, I'm able to identify. Now, when you're having, or you're talking about quantum applications, you should be, and particularly communication, your adversary is a high-tech quantum lab. He's a quantum adversary. He has all the powers given by the quantum physics. So now, since it's a mathematical framework, so we can actually analyze and understand how much information has been leaked out. What are the possible errors, or what are the possible technologies which can happen in future to extract, which can extract information when I'm sending photons, information through photons. So that is taken into account, and that is used during the analysis to generate symmetric encryption decryption keys. So using quantum key distribution, I'm solving the problem of generating symmetric encryption decryption keys. No need to say them separately because symmetric means they are same.
Okay.
So we are generating them at two ends in presence of an eavesdropper over a insecure link.
Okay.
So and guess what? Information has to flow from one place to the other. So we use photons as they are the flying qubits.
Okay.
Okay, so any communication or any QKD associated with satellite, terrestrial, free space, they all use photons.
Okay.
So computing also uses photons.
Yeah.
But in communication, it is always from one end to the second end. Here again, it is important for us to understand that there are two topologies possible. One is prepare and measure, where you are, because we are dealing with photons, quantum entities, so we have to generate the photons, we encode them, and then we send it through a transmission channel. It can be atmospheric free space, or it can be standard telecom fiber, it can be through satellite, right? And then we have the receiver station. So this is prepare and measure, okay? So there's another good thing, maybe if you ask me, then I'll be talk more about it, is the measurement. So it's prepare and measure and doing the measurement, and thereafter you have lot of processing stacks,
right,
where you are able to extract the information after converting it from analog to digital, or from the, there are a lot of steps involved. The other one is the entanglement ones. The entanglement is where you have a Charlie, we say, who generates the entangled photon pairs and distributes the entangled photons to the two receivers, and the receivers thereafter perform QKD, or a quantum safe communication.
Yeah.
So these are the two topologies, and of course there are many protocols. The security of establishing the security of protocols is very difficult, and there are a lot of, it's a different area altogether. Since these products are core technology products, and they are at a very higher TRL level, but not yet to the level where it has been standardized. So yeah, I think we'll discuss that
later. So ma'am, what we just spoke about is how QKD makes the traditional encryption methods more secure.
Yeah.
Right.
Yeah.
Let's move on to the random numbers now. What are truly random numbers important for security? Why are they important for cyber security?
Okay. See, the requirement of random numbers is very basic, and when we talk about randomness, we have been using either random numbers generated from mathematical algorithms. We call it pseudo-random numbers, and that usually follows a seed, so it becomes predictable, right? Now, the other category is the hardware-based TRNG, hardware-based random numbers. So it's a hardware, so it either follows a classical physics or it will follow quantum physics. Okay. Now, NIST has been, has prescribed rules to generate hardware-based random numbers, and I think some 20-30 years back also NIST was talking about a QRNG. The difference being the QRNG, which was at that time, had very less output. It was few bits, and then it had to be buffered. So wherever you are putting or you're concocting an algorithm, there is no way to say that it is going to be forward secure, or you cannot decrypt it later. So those challenges are there. But today's QRNG, particularly from the quantum optics, they give throughput of the order of gigabits.
Right.
So that eliminates the requirement of having any or doing any buffering, right? So that is the reason QRNGs are preferred. They are the state-of-art random number generators in many strategic agencies, and people have been adopting it globally, right? The challenge, of course, comes because of the form factor, and so this is something which is actively being moving. But yes, as and when the technology is also evolving, there can be some other methods also to generate high quality quantum random numbers, which may have a smaller form factor as well. So this is how it goes.
Okay. So ma'am, while we have spoken about QKD and QRNG, are there any limitations for the adoption of these two? And are these technologies already being tested or deployed in India?
Yeah. So there are two questions. One is
limitations.
Limitations.
Yeah.
Okay. So when we talk about QRNG, I was trying to touch upon that matter briefly in my your previous question. The thing is, there are no standards. it's evolving. There are global bodies who are working on bringing out standards on the QRNG architecture, on prescribing what are the possible quantum entropies which can be used, right? So that is happening, but again, since it's a hardware, so you have to understand, what are the possible loopholes, where is the deviation between theoretical randomness, and the practically what comes on table, okay? And with respect to QKD also, as I told you that QKD is one of the solutions to transition to a quantum safe world. And while I was talking about this, you must have realized there are a lot of electronics, optics involved when I'm saying I'm generating single photon states, I'm doing quantum measurement. So there is an interdisciplinary engineering which comes into action. And because of that also, stability, infrastructure adoption, all that comes into play, and it is usually point to point. At the same time, you have interoperability that has to be addressed. Then you have one of the challenges is denial of service attack. Yeah. So what if there is an interruption in the channel itself? So how do we go about it? And how do we integrate the numbers from where it is getting generated to the application end? So there are these challenges, and minds and bodies around the world have addressed them, and this is just evolving. So when we say classical world, it has been 70 years, right? And the quantum is evolving, and we are in the very basic beginning stage. And if you look at the HC standards, even DOT is actively working on bringing out standards, in national standards on QKD, PQC and QRNG.
Okay.
The Indian users are also becoming aware, so these issues are getting addressed.
Thank you, ma'am. Just to let you know, a lot of people in our chat are asking about what the information that you are giving, and they are very happy learning about them also. But the questions about specific question about where India stands, where it will be, I'll be taking those questions again with you, maybe, when we start taking user questions, and we'll again talk about them. Going forward, ma'am, if I talk about the future, what does the future look like, and how can we make it work over long distances without losing the quantum signals?
Yeah, that's a good question again, because we were till now discussing very local activities, right? Now, I would also like to mention here the ranges. When I'm talking about terrestrial QKD, it can support till 150 kilometer. Some breakthrough protocols can go a little longer. So then the challenge comes on a longer link. And we cannot have quantum repeaters. Quantum repeaters will come if you have single photons, you have entangled photons, then the quantum repeaters will come, and there is an R&D happening, TRL level, say 4 to 5. Soon it will be in the market. So that is one part, and the second part is the satellite QKD, which will cover thousands of kilometers. But again, it will have its challenges, as in putting the ground stations everywhere is not feasible. And you'll have to establish the link with the satellite for a very, you get a very small, limited time to establish that network. And therefore, you have this gap, the terrestrial and the satellite. Now, in future, you would need full time, all location, and all modes of transmission to be engaged for a quantum internet or for global quantum communication. And their role of aerial vehicles or aerial platform is going to play a very critical role. Now, these comprise of drones, high altitude platform vehicles. So these can, and they also help because they actually add agility to the entire thing. They are reconfigurable, they are cost effective, they can be supplied on demand, right? So we are actually working on aerial communication. So we would want to establish quantum link using drones, and once we have drones, we can also climb to high altitude platform. But at the same time, let me also acknowledge the national players. TIFR is also working on quantum communication through high altitude platforms. ISRO is working very actively on satellite QKD. We have C-DAC actively working on terrestrial QKD. So once all these players put out their products and integrate, so you can establish a link. And that is a good beginning for, providing all location coverage.
Ma'am, you mentioned about ISRO and DOT. So you spoke about the government organization. So I would like you to detail on what are the government initiatives in this area.
Sure. So, so Indian government had been proactive in this area. So if we start with MITI itself, so MITI has been funding projects on quantum communication as well as quantum computing. MITI has been supporting industry, academia collaboration, industry, government R&D houses collaboration. It's very much active in Bangalore. In Pune, we are working on high-tech technology products. Then ISRO is working on satellite QKD. We have DST, the National Quantum Mission. It's in news and it has pulled a lot of attention globally. And there is an investment of about 6,000 crores to fund research, to support research in quantum communication, computing, metrology, and sensing, and materials. So there are national thematic hubs also established, and if you see their map, I mean, almost all citizens are engaged, and the best places to begin the technology transition is through academia, right? And you will see that as National Quantum Mission and the PSA office, they have involved AICTE. AICTE has, proactively launched the education courses, quantum education courses in undergrads and in post-graduation. MITI has started the QCAL lab, Quantum Computing Applications Lab, where they had provided, where AWS had provided the quantum hardware, access to quantum hardware. I have also applied to that, and it's a wonderful kit to play around and to see different hardwares, because quantum hardware can be realized using ions, using atoms, using photonics, using superconducting artificial qubits. So it provides the student hands-on different technology. You see what are the challenges in terms of the performance, fidelity of the qubit. So that's a very good beginning. MITI also does collaboration with different countries. There is strategic collaborations which happens, and there are international events which government bodies organizes. The DOT is active on involving global partners, bringing them into the telecommunications domain. So DRDO is very active, and there are government R&D houses which are proactively working under the guidance of their ministries to bring to work on these projects.
Thank you, ma'am. And ma'am, how about if we specifically talk about any key technology developed by C-DAC in this area?
Right. So here, as I mentioned before, we had recently demonstrated mobile QKD. So mobile QKD would mean that there is a mobility involved. It is not static, it is not rigid, and and it addresses the engineering challenges of taking the system, the high-tech system, out from the lab and putting it anywhere. So I would like to request you to show a video where you will see the two racks. One is the quantum transmitter node and the receiver node, how they come out and then they perform the task.
Sure, ma'am. Thank you for the video, team.
Thank you. So here you must have seen that a rack moves out of the of the lab, and it goes to the parking area. So that can be any place, right? So we need not, we are not limited to doing this demonstration within the premises. We can go anywhere, and the rack is my prepare and measure. If you remember, I spoke to you about prepare and measure. So we have done B92 QKD. It's a QKD protocol in 1992, and it uses 2 non-orthogonal states, again quantum physics into action. So the rack comprises of 3 units. The first one is the optics and the associated drivers and the control electronics there, and then you have the hardware processor. You have the time and synchronization unit, because you are actually generating the photons, you are encoding them, and then you are sending it to the other station. You have to do quantum measurement on that module, on the coming photons. So there has to be a precision of picoseconds, nanoseconds between the two, right? And as I had told you before, that we are not distributing the key, we are generating the key simultaneously. So, and there is no key information which is passed. So the key never travels. It is generated in those 2 racks. So then how do I decipher? There is a lot of post-processing steps. Okay, so primarily we say most of the times that what time did you receive the signal, because here the signal is 1 photon. So you will be able to measure that 1 photon which is sitting in a superposition of multiple pulses.
Right.
So you will not be, you will not have any prior idea of where you are actually getting the timestamp. So that translates into symmetric random bits. And then there is a lot of pre-processing in it. So there has to be a communication also. Now imagine difficult terrains, availability of any network. So we will be able to survive in those conditions, and we have used drone RF for doing the classical communication, again, which is discussing about the post-processing. And we will be also able to move from, at present we are synchronizing using GPS, but we can move. There will be a costly solution, but we can move to a GPS denied environment as well. So this is a mobile unit, and we are now going to translate that into a payload, and you will be seeing a drone, mounted it on a drone, and then the drone is flying, going up and establishing a link between 2 ground stations.
Congratulations for the lab, ma'am. Thank you. Ma'am, how about the Indian industries? Are they ready for the adoption of quantum technology?
Yes, I think they are gearing up to. See, I am about 18 years old in this domain, and when I associated myself with the first industry, which was about, say, some 7-8 years back now, there were very few, 1 or 2. Now, and with the support of the government, there are around 45 to 50 startups in India, and which means, and they are also generating revenues, which means that there is an increasing level of awareness in the industry. They are putting the quantum readiness because of the Moscow's law, as I told you. You know, that plays a very important role. So people are gearing up to this transition. Now, again, I must say that the standards are, you know, it's drafted. It is also available, but since it's dependent on a new technology, so it is time that we buy and make organization ready, study the equipment, understand how to you know, make it work, how to integrate it, what are the challenges you will be facing, so that once if you hear a noise about that there is a quantum computer up in the market, you don't have to go on a whiteboard. You know, you start from somewhere.
Yes, right. So, ma'am, since India has already started, you know, working towards it, how is the global industry reacting to the developments in Indian quantum ecosystem?
Yeah, so this is interesting because now, since I'm in a government organization, we understand the scenario, and lot of strategic collaborations, lot of capital investment is also done using government initiatives. And you will see a high level of validation of what India is doing through the participation of foreign foreign market and foreign government bodies in our international conferences and organizations. Recently, C-DAC had organized Supercomputing India, where I found so many global quantum startups, and even the ratio of Indian quantum startups were also high, and even the industries and R&D organizations were putting things on table.
Yeah.
So, and the world has been, I think it's warm and it's encouraging, and also they are looking for collaboration, and from in different levels, industry, government R&D, academia, they would want to now exchange students.
Right.
So that's going in a very good direction.
Thank you so much, ma'am. Here I'll give you a very short break and thank you for explaining things to us. So friends, बहुत ही रोचक चर्चा चल रही है. This is the point where I want to pause for a moment and thank all of you for joining us and writing your questions generously in our YouTube chat. The chat is buzzing and we absolutely love your energy. जिन लोगों ने अभी अभी शो ज्वाइन किया है, मैं उनको क्विकली बताना चाहूँगी कि आज हम बात कर रहे हैं उन क्वांटम टेक्नोलॉजीज पे जो इंडिया की डिजिटल सिक्योरिटी को अगले स्तर तक ले जाएंगी. और अब आपकी बारी है, क्योंकि अब हम आपके सवाल लेंगे. इफ़ यू हैव any questions on quantum security, quantum communication, QKD, QRNG, cyber security, data privacy, quantum related, तो आप चैट में लिखिए. डॉक्टर बैनर्जी will try to respond to all your questions during the show. मैं आपको याद दिलाना चाहूँगी कि आपके सवाल आपको डिजिटल इंडिया क्वेश्चन निंजा भी बना सकते हैं. सो अपने क्वेश्चंस लिखने में हिचकिचाइए नहीं. कोई भी क्वेश्चन आसान या मुश्किल नहीं होता. क्यूरियोसिटी है तो पूछिए. सो जस्ट कीप दोज क्वेश्चंस कमिंग. लेट्स स्टार्ट विद द फर्स्ट क्वेश्चन, मैम. It comes from Indrani Banerjee. She is saying that countries like China have already reached milestones like making their own quantum computers. Where do we Indians stand in the race? Can we also become a superpower and maybe lead this race?
Yes, I think with the current government initiatives and as I told you that there is a very warm interactions with the global world. So India is slowly and steadily moving in that direction. India actually houses one of the first quantum computers in NMR, but however it is not scalable. So now we are looking into different other technologies. India houses 3 to 4 superconducting based quantum facilities in India, and 2 of them in ion trap, in neutral atom. So India is moving slowly but steadily.
Thank you, ma'am. The next question is from Think Privacy. Hello, ma'am. If a hacker stores my or anyone's encrypted data today, will they be able to decrypt it in the future once quantum computers become available?
Yes, there is a very high likelihood, considering the data, the encrypted data, if it is encrypted, then as I told you, the mathematical problems, if there are quantum algorithms that addresses that, and they are, so it is under threat. But if it is not like your passwords, which you keep changing, maybe in a year or 2, but these actually applies to national secrets, which you would want it to be kept for maybe 10 years, 20 years, 30 years. So those areas are in very high danger.
Thank you, ma'am. And next question is from Pradeep. He is asking, how does India's national quantum mission contribute directly to improving digital trust and privacy for every citizen?
So here again, the National Quantum Mission is doing a fantastic job, and they are actually reaching out, and the industries are also reaching out to them. They establish links between the user and the academia and the government agencies. They are trying to bring this interaction out and enable the engagement. So if you have, or if you're interested, I think there is a cell in National Quantum Mission which will take it further.
Okay. Vinod Yadav is asking, India is rapidly rolling out UPI, Aadhaar and DigiLocker for daily use. Given the quantum threat and how it's now decrypt later, what roadmap government is taking to make these platforms quantum safe?
Okay, so here again, I would say because of the proactiveness of organizations, of ministries like MITI, they have recently, I think in July 2025, there is a white paper between CERTET and Secretary MITI has actually given it out. It talks about the transition of cybersecurity to the quantum safe era. So yes, there are plans, there are discussions, there are deadlines being given, and things are moving again in that direction.
Okay. Next question comes from Dayar Maurya. He is asking, if a company uses old encryption and data is leaked later because of a quantum attack, will it be a DPDP violation?
Well, this is a trick question, and I think I would not like to take that. But this is a concern. This is the, this is where the citizens' awareness comes in.
Yeah.
It's good to ask, and you have to engage with the vendors, ask the vendors about their roadmap to the quantum transition.
Right.
There is a mandate by US and Europe to transition to PQC by 2035. So where are we? What is your roadmap? And there has been a huge wave of MNCs actually working with the global bodies, standard bodies, in converting or bringing out the quantum safe products. So those are happening, and please don't put your question aside. This is the right question, but may not be the right platform. This has to be addressed.
So I'd request you for asking Daya Maurya that you can write to our team at our email ID, which is askourexperts.negd@digitalindia.gov.in. हम उसको आगे भी दिखाएंगे आपको. Or you can reach out to the DPDP team also. You will get the necessary email IDs on our website, which is meti.gov.in, and you can reach out with your question to them, and probably you will get the specific query that you have, you will get the answer there from our experts from the DPDP team. Ma'am, let's move to the next question. It comes from Arjun Kumar. He is asking, what training programs or online courses are available in India in the field of quantum security or QKD that students and professionals can join?
So lot of awareness programs are being organized, so you can connect with either C-DAC, you can also connect with DSCI, you can connect with, if you look at, if I tell you to connect with academia, because this is a very deep research field, and it should be interesting to you, and it should actually address your query rather than taking you deep and broad and everywhere. So I think you should connect with some special organizations, R&D organizations, if they are coming out with some education modules. Recently, C-DAC, we have actually we brought out a module for managers, right? And so that was a good move. So something of those initiatives has to be taken by the organization. They can ask experts to join them and come out with a course addressing a particular area, a specific application area. So that may be helpful. Otherwise, internet is full of contents, and there are so many schools, startups on quantum education which are actually taking it further. So that can also be of some help to you.
Right. Ma'am, before taking any more questions, here's a quick myth or fact session that I want to do with you. And I'm sure that session, that short myth and fact session will answer to many queries that I have received in the YouTube chat also.
Looking forward.
Thank you, ma'am. So, ma'am, I'll read out a line. You just tell us myth or fact or why and why. So, let's see how much of the quantum security is truth and how much is the quantum confusion. So 1, quantum security means hackers will disappear forever. Myth or fact?
Myth. Hackers will evolve. So they will be learning the tricks and trades of that. So we, on the other side, we have to enable this quantum transition fast, because hackers are evolving and they don't need a government funding.
Two, quantum security is only for scientists, not for people like us.
No, this is it's a
Myth.
quantum confusion.
Right.
So it's a global effort. It is directly relating, involving the citizens. So yeah, absolute myth.
Quantum security can detect hacking attempts instantly.
Hacking affects any hacking on the quantum link, on the key distribution link. That's a truth.
Truth. Next, quantum computers are science fiction. This threat is far away.
No. Quantum Valley, we are going to, So as I had told you before, India already houses the first, one of the first quantum computer, NMR based, and we have superconducting ion trap, NMR, actively research is pursuing there. It is a reality. It is just waiting to happen, and trust me, when it happens, the news may not come instantaneously. We have to be careful. Yeah.
Next, quantum random numbers are more secure than computer generated ones. Myth or fact?
Fact. With the precaution that the loopholes, and it's a hardware device, so that has to be engineered. So it depends upon the engineering you're putting on table. But definitely a TRNG, and that too a QRNG. Why? Because QRNG they use the intrinsic nature of quantum physics. So it is mathematically certified. So I cannot say any certified PRNG, but I can say a certified QRNG with entanglement. So that is the thing which we are, which is out there.
Right. Next, quantum security helps protect future generations' data.
Yeah.
Myth or fact?
Fact.
Absolutely. Yeah. Quantum security means changing all our phones and apps. Myth or fact?
So it can be a fact because I told you that QRNG is hardware, QKD is hardware, PQC is software. So it depends, and it depends upon the bandwidth and latency. So it's a tricky question, but definitely there will be upgrades.
Quantum security is too expensive for a country like us.
We have already products in markets. Quantum startups are there, which is bringing out QKD, QRNG, PQC, even quantum computers are there. So it's a myth, yeah.
Quantum security strengthens Digital India's backbone.
Of course.
It's a fact,
Yeah.
right? Lastly, in quantum security, spying itself is the alarm.
Yes. So any act of measurement, monitoring on a quantum system, it actually collapses a state in a manner that it can be randomly incorrect, and that is an indication of error rate. So we watch our error rate very carefully. If it goes beyond a threshold, there is some disturbance happening. It can be because of environment, because they are very fragile, or it can be because of an adversary. And the smart way is to think it's an adversary. Now, during a quantum attack, because it is all a mathematical framework, there will be some attacks which will not be visible, or the footprint will not be there on the error. But again, the quantum physics tells you what kind of attacks those can be. And we are accounting for those attacks which has not happened or which can happen already during our analysis.
Thank you, ma'am. Thank you for being so quick with your answers. Because of the paucity of time, let's take two more questions from our audience. One is from Manisha Mantri. She is asking, she is saying that thank you, great discussion. Could there be a use of quantum computing for the general public? If yes, what could be the timeline, the way we are progressing? And what could be the use cases?
That's a very good question, interesting one, because then when is the time that the citizen starts interacting with it? Actually, the time is now, because quantum computing, you do not need a quantum computer. Actually, you have simulators. C-DAC, in fact, has QSIM, has launched QSIM. C-DAC has launched Quniverse. So there are platforms available, and there are global industry also who are putting forth simulators, and even a simulator which can do for about say 10, 15, 20 qubit is good enough to have a hands-on. The thing is, we have to understand how quantum is going to add to your advantage. What is the problem statement one is working on, and whether quantum actually addresses that computational problem or not, because quantum will not solve everything, only certain class of problems. So what are those class of problems that can help you? And I think a lot of literature material are also available. And so we have to act now, and I'm sure you'll find things of your interest to take it further.
Thank you, ma'am. Let's take the last question. So it's from Shashank Mishra. He says, NIST has finalized PQC standards. Should India adopt them directly for Digital India platforms or customize via the National Quantum Mission? And what are the first pilot steps?
It's again a very quick question, and again very happy to have this question here. See, when NIST is putting forth some final candidates, and that is after a rigorous scientific analysis. Now, when they are doing that analysis, they are also considering the possible quantum attacks, or if there are some quantum algorithms which can actually attack the algorithm, the quantum algorithm itself. So a lot of minds, time, energy has gone into it. So any deviation from that has to be calibrated and validated by domain experts. And if that is done, then it's a good thing. So without just saying that it cannot be done, let us be open. Let us be look at it from a very scientific perspective. And if it is possible, and if the expert says it, then it is okay.
Right. Mm-hmm. Thank you so much, ma'am. Thank you for letting us know about this new subject of quantum computing for office in such a detailed manner. So दोस्तों, I'm sure काफी ही knowledgeable session रहा आज का. I'm grateful to all of you to making it even more interesting with your questions, with your quantum related questions, and I enjoyed a lot, I'm sure. So दोस्तों, ये 36 एपिसोड काफ़ी ही वैल्यूएबल था. तो प्लीज़ डू शेयर इट विद योर फ्रेंड्स जो टेक में हैं, जो स्टूडेंट्स हैं, जो कोलीग्स हैं, क्योंकि क्वांटम सिक्योरिटी हम सबकी जिम्मेदारी है. एंड इफ़ यू हैव एनी मोर क्वेश्चंस, या आपके कोई क्वेश्चंस जो अनआंसरेबल रह गए हैं शो के दौरान, डॉक्टर बैनर्जी ने स्पेशली इस प्रोग्राम के लिए हमें अनुमति दी है कि हम उनका डायरेक्ट ईमेल आईडी आपके साथ शेयर करें, सो दैट यू कैन डायरेक्टली रीच आउट टू हर and write your questions to her. She would be happy to help. So kindly write her email ID. It is ANINDITAB, anindita.b@cdac.in. For any of your quantum communication related queries, you can directly reach out to her. For any other queries related to the show or our past episodes, you can reach out to us on our email ID, which has been specifically made for Ask Our Experts, which is askourexperts.negd@digitalindia.gov.in. और अब बारी है हमारे डिजिटल इंडिया क्वेश्चन निंजास के नामों को अनाउंस करने के लिए. वैसे तो आप सभी ने बहुत ही बेहतरीन क्वेश्चंस पूछे हैं, जिनसे हमें इस सब्जेक्ट के बारे में काफ़ी कुछ जानने को मिला. But as a rule, as a process, I'll take out 4 people. So their names are Indrani Banerjee, Shashank Mishra, Arjun Kumar, and Manisha Mantri. Congratulations to all 4 of you for winning the Digital India Question Ninja reward. I'll request you to kindly email us your details. In details, I would want your email name, the username that you use on your YouTube, through which you have sent the query, the question that you have asked, the address where you want your reward to be delivered, and your phone number, because the delivery person would be needing that number, to our email ID, which is askourexperts.negd@digitalindia.gov.in. इसी वाले email ID पे आप अपनी ये details हमें भेज दीजिए. Our team will reach out to you. If you want to watch any of our previous episodes, today is the 36th episode. So इस episode को और इससे पहले वाले episode को अगर आप देखना चाहते हैं, so you can reach out to the Digital India official YouTube channel. वहाँ पे आपको एक Digital India Ask Our Experts की playlist मिलेगी. उसके अंदर हमारे सारे episodes lined up हैं. डिजिटल इंडिया इनिशिएटिव्स के बारे में और जानकारी के लिए आप हमारी वेबसाइट digitalindia.gov.in एंड negd.gov.in इनके ऊपर जा सकते हैं. अगर आपको कोई भी टॉपिक इंटरेस्टिंग लगता है जिसके बारे में हमने अभी तक बात नहीं करी है, जो आपको वेबसाइट पे दिख रहा है, तो काइंडली लेट अस नो. हमें ज़रूर हमारे ईमेल पे लिखिएगा. हम आपकी सजेशंस को देख के जानकर और उसके ऊपर काम कर बहुत प्रसन्नचित होंगे. नेक्स्ट वीक हम फिर मिलेंगे एक नए टॉपिक के साथ, एक नए एक्सपर्ट्स के साथ और आपके सवालों के साथ. तब तक के लिए मैं आपकी होस्ट शिप्रा एब्राहम आपसे विदा लेती हूँ. नमस्कार.